Λοιπόν, έχουμε 2 λεπτά ακόμα να ξεκινήσει η δεύτερη... Okay, I should speak in English. I'm sorry of any mistakes that I'm going to do in spelling. We are very glad that we have together with us in this second colloquial talk on the frame of the Sai Cafe of the Hellenic Mediterranean University International Relations Office. We are very happy, me and George Kavoulakis, professor in the Department of Mechanical Engineering from Hellenic Mediterranean University. We are the 2 moderators of this action. We are very happy to have with us Melina, Professor Melina Kotti. She's a chemist. She has a PhD from the University of Ioannina, I think, if I remember correctly, in 2006. And since 2007, has joined our university as an adjunct professor, and now she's an assistant professor. And very soon, I wish her to become an associate professor. So, Melina, I would like, on behalf of myself and George, to thank you very much to be with us. It's a great honor. And the floor is yours, Melina, in order to start your presentation.
Thank you. I will share a screen, and if there is any problem, please inform me. I think it's okay now. The title of my presentation is, as you see, environmental quality, environmental protection, a global approach. I am assistant professor at the Department of Electronic Engineering. My ex-department was Natural Resources and Environmental Engineering. Now I'm at the Department of Electronic Engineering that belongs to Hellenic Mediterranean University. Hellenic Mediterranean University is, as you know, one part of the European university called Athena. It is a new one, established university, and this could not be feasible if their Professor Kostas Petridis wouldn't work so hard. So I want to say congratulations to Professor Kostas Petridis because he had a great effort on for this university, and many thanks also to Professor Kostas Petridis for his invitation to this Sai Cafe colloquial talks. My research activities is about water and wastewater. I have already said this to my short abstract. For example, technology for quality control of environmental samples, water and wastewater. Technology for water and wastewater treatment, optical spectroscopy, chromatographic techniques, high performance liquid chromatography, gas chromatography, extraction, isolation, and pre-concentration of organic compounds from environmental samples. And finally, the statistical treatment of environmental data, because without statistical treatment, we don't have reliable results, and we can't present them in a paper, for example, in a manuscript. My teaching activities, as far as the graduate course concerned, are chemistry courses, labs, theories, water treatment technology, water quality. I have taught also sociological approach for natural resources and environment, and the new one courses in the department, the restoration of water and soil resources, physicochemical processes. I have also taught in other courses, but not in this university. In master course, I have taught already advanced geochemistry, and the course titled environmental chemistry and contamination. The basic terms, or we call it keywords, or the terminology for a scientist that works about the environmental protection are the following, in my opinion. First, what is environment? What is environmental quality? Environmental pollution and contamination. Fourth, environmental protection. Restoration, environment, ecosystem, sustainability. These are the most representative, in my opinion. Of course, there are other terms, scientific terms, but I think that these, from my experience, these are the most important. What is environment? In a sociological approach, environment is called a dynamic system that is developed and adopted through the effects and reactions between biotic and abiotic factors that are part of it. Biotic factors are the factors that have life. Abiotic factors are the factors that have no life. For example, substances, sun, light. Biotic is everything that has life. The natural environment is contrasted with the built environment that consists of the areas and components that are strongly influenced by humans. A geographical area is regarded as a natural environment if the human impact on this area is kept under a certain limited level. It's not affected, with other words, by humans, or the effect is very low. What we call environmental pollution and what we call environmental contamination. I say these two terms again and again to my students, and I demand from them to know this discrimination. Pollution, when we say pollution, we mean the addition of chemical substances and or addition of heat in an area or water body, etc. When we say contamination, we mean the addition of microorganisms in a water body, area, or something, or somewhere else. So this discrimination should be, they should know this discrimination between these two words. Now, how can we estimate the quality, the environmental quality? We use for the estimation some quality parameters. These parameters may be either physicochemical parameters or biological parameters, and the last one part can be the determination of pollutants. Pollutants are the compounds that pollute, as I said, the environment. Some representative physicochemical parameters that we always in monitoring studies check are pH of samples, temperature, electrical conductivity, metal ions, hardness, total hardness, carbonate hardness. There are also other, but these are the most usual, the most important. Biological parameters. We check for total coliforms in a water sample, for example. We check for fecal coliforms like Escherichia coli. These are the most important ones because somebody can check if a water sample, for example, has viruses or something else. But the most usual are these two. Pollutants, chemical compounds. What are the pollutants? The pollutants can be either polycyclic aromatic hydrocarbons, PAHs, as we call it in abbreviation. They can be solvents, organohalogen compounds. They can be polyfluorinated biphenyls, PCBs. They can be heavy metals, mercury, nickel, cadmium, chromium, etc. They can be organophosphorus compounds and many more. For example, the last one are applied as insecticides, pesticides. The previous one can be used in other our daily life or from factories for a specific use. A scientist that works about quality, environmental quality, should have must have knowledge about the directives that are established for the European Union. The most abundant, let's say, directive is the directive in 2000 that had been established in 2000, number 60. This concludes of an indicative list of the main pollutants. So we have to follow this directive to every time we check the quality of a sample. This is about the water. Previous directives, as you see in this table, are have been established from 1975 for surface water or for bathing water, freshwater fish, shellfish, groundwater, other directives for drinking water, etc. We have a list of directives, and as I have already said, the abundant is the 2000 directive, and of course there are other directives following this nowadays. The water cycle is a figure that every scientist that works on water should have knowledge of. What is the water cycle is a figure that, or else called hydrological cycle, is a figure that somebody can see all the paths that water follows from the surface of the earth to the atmosphere and back to the surface of the earth. And of course, water goes to the ground and goes up and evaporates and then condensates again and again. So it's a figure, a characteristic figure that somebody and the students have to know about this water cycle. The point and the non-point sources. What we mean when we say point sources of pollution and non-point sources of pollution. Point sources are the ones that can be identifiable, and usually they come from one single place. Non-point sources are the sources that are unidentifiable or difficult to identify, and they come from many places. As you can see in this figure, for example, a plant, a wastewater treatment plant, is a point source of pollution. A factory is a point source of pollution also. Non-point sources may be the city's trees, or maybe some the land that is rural. Also, they can be the farms that we don't know. For example, somebody has a garden and applies pesticides or something to improve the production. So these are the non-point sources. For the protection of environment, now, what can we do? We can take measures for facing the deterioration or else called degradation of the environment, or we can take measures for preventing the degradation of the environment. The last of these two include also mostly something that is very strict. For example, in order to prevent, we have strict laws. So somebody is afraid of polluting the river or a stream or something else. The measures for facing the deterioration are the ones that we will deal in the next. What can we do to face the deterioration of the environment or to treat? We can use treatment methods. These can be physical and or chemical ones. This depends on the degree of pollution or contamination. We may apply disinfection, for example, to get rid of the microorganisms. This could be physical or chemical method. Filtration, physical method. We can use adsorption on some materials in order to get rid of, let's say, the pollutants. We can use coagulation, chemical method, or sedimentation is a physical method in order to treat water and wastewater samples. So in this figure, you can see a typical layout of a water treatment plant. These figures figures I have in all my lectures to the students, and I want them to know how the steps that we follow in order to treat the water and make it potable. These are some of the steps, some treatment steps. It not include all of them. Of course, a wastewater treatment plant consists of much more treatment steps because wastewater is much more polluted than water that is abstracted from a aquifer, for example, or a lake that is not polluted. You can see some steps like sedimentation, flocculation, disinfection is, of course, always the last one of the steps in order to make the water potable. The next term that I will refer is the restoration. Restoration, what is? It is an effort from people to bring an already degraded ecosystem to its initial situation or about or close to its initial situation, because it's difficult to make it the same that it was before. For this purpose, we can use either in situ methods or ex situ methods. In situ, we mean in the same place. Ex situ, we mean that we take part of the polluted or contaminated area and treat it in somewhere else, and then return it back to where it belongs. Ecosystem is a group of living organisms that live and interact with each other in a specific environment. It's this term, we have some ecosystems. The most important groups are landic ecosystems. Landic, we mean the standing water like lakes, ponds. Lotic ecosystems, moving water, flowing water, rivers, streams. We have terrestrial ecosystems. For example, for a forest can be a terrestrial ecosystem. Marine ecosystems with the sea. Sustainability is the last one of the terms, and I have found three definitions for this term. It's a modern one, let's say, term about sustainability, or else called sustainable development. The first definition that has been created by the United Nations World Commission on Environment and Development says that sustainability means the ability to meet the needs of the present without compromising the ability of future generations to meet their our needs. The second definition that has been created by the International Union for Conservation of Nature says that sustainability is the capacity to improve the quality of human life while living within the carrying capacity of the Earth's supporting ecosystems. And the third one definition by an environmentalist called Paul Hawken that says sustainability is about stabilizing the currently disruptive relationship between Earth's two most complex systems, the human culture and the living world. Somebody can keep one of the three definitions. It is the most modern term, let's say, sustainable development. Many people work about sustainability. The next one is about the publications about water quality that I have already done. These two, as you see, are referred to the water quality from lakes, from sediment, the first one, and the second one, I have studied the water quality of a river in northwestern Greece. Also, about water quality are the next, the two that you see in this transparency. It is about the characterization of Almirosa River here in Crete, the study of the physicochemical parameters, but and also from pollutants like polycyclic aromatic hydrocarbons and anionic detergents. And the second one is about the fluorescence compounds that can be pollutants or not pollutants in the river. About wastewater quality, I present you these publications that has been done when I was a PhD student. It's about the monitoring or a study of wastewater samples and the classification of them with chemometric methods. And the water protection. These two publications have been done here in our university. The first one, we have applied coagulation to treat a synthetic water sample. And the next one was about absorption in order to treat a water sample from the cationic surfactants. I have also, in case to suggest a proposition for collaborations with other universities, other people, other scientists. We can develop a network with environmental data and with some scientists from other countries. We can develop new methods for characterizing the quality of the water and the wastewater samples. And the last one, we can develop new methods for protection or find new materials. For example, in order to treat water of absorption materials that is very famous in nowadays. The final is some advice to young scientists. Of course, as I can see, most of you are already very experts, so you can ignore this. But if we have scientists in their early scientific steps, I advise them to work hard to finish their work, study hard, do not be disappointed because failure is most the most probable thing to happen, and the success is the less probable thing. But this is this is research. Unfortunately, we keep only the few things that neglect the more, and do not stress, because health is over upon everything. Thanks for your attention. That's this is the end of my
Yes,
presentation.
Melina, thank you very much. Please stop sharing your screen.
Just a moment. Okay, I should just give this.
Okay.
I finished in less time than predicted. I
Never
told
mind.
you from the beginning. I speak quickly, so I finish earlier always. So I am available for questions or suggestions or propositions for collaboration.
I have some questions, but before I will start my questions, I don't know if someone from the audience has a question to ask Melina. So my question, I have two questions. First of all, I would like to learn from your side how your research is linked with what did you present. I mean, you presented a list of publications. So can you please explain to me how your research has impacted this topic? I mean, what are the new things that you have done as a researcher, and what is your plans towards the environment and water processing, because it's the first time that I have realized that you are working very close with the water treatment and restoration.
Yes, as you can see, all of my publications is about water quality, wastewater quality, and of course, and water treatment. These terms I have referred in the beginning. What is water quality? What parameters we measure in order to evaluate the water quality? We measure physicochemical parameters. We measure some pollutants. Of course, the pollutants are many compounds. So I have chosen some of them in order to detect if their existence to water or not. About water protection, water treatment, I have applied two methods, one physical and one chemical, and I have found that it was effective in order to remove some pollutants from water.
And Melina, a second question that I have, because I don't know, is like how much the size of the pollutant affects your detection or your treatment methods.
Of course, if we have, and we wish, of course, to have low concentrations of the pollutant, very low, but this makes hard to us to pre-concentrate the samples, because we have to lower the concentration, the measured concentrations again and again, from microgram per liter, for example, we can go to nanogram per liters. And the science and the methods should be improved again and again in order to detect the lower concentrations.
So detection systems like, you know, porous materials that we can work as a filters, like a net, or chemical or optical methods. Do you have on your mind some of these, of the already employed detection techniques?
I have in my mind mostly about some new materials to try if they are effective or not in order to remove the pollutants.
And what are the characteristics of these materials?
Uh,
Of course, they should be solution
they
process.
should be a porous materials in order to keep the pollutants in their pores.
So the pores should be smaller than the pollutant size. Am I right?
Yes, they should be, the best thing is to be very small, but and from the pollutants with the small pores, we have to choose. It's not everything effective. Some of them can be effective.
probably, you know, it's also, I think it was with us, Thanas Kucholelos is doing a lot of work regarding, I mean, they dope, it's not only the porosity, but also they dope, you know, this kind of porous materials with other heteroatoms that they react with the pollutants and so they destroy them. Anyhow, I don't know if there are any other questions from the audience.
I have a question, Kostas.
Thank you, Nektarios, to be with us. Nektarios Papadogiannis is like vice rector in our university, so it's a great honor to have him with us. And I would like also to say hi to Nisim from Israel, that he's among us. They have a great expertise in Israel regarding water. So probably Nisim has another question. So Nektarios, the floor is yours.
I'd like to thank Melina for the very nice talk. Also thank Kostas and Giorgos Kavoulakis for the organization of this Sci Cafe. Just a question, the experimental tools that you have in your lab is enough for this kind of research? How we can improve it, or how we can, the collaboration within the framework of Athena project can maybe improve with other labs the ability, the experimental ability, and in your dreams for the improving of your research in this kind of very important thing, especially for the Mediterranean era. Thank you very much.
Okay. We can improve, of course, all the methods what we deal till now by, for example, and the new sensors for detecting some parameters. As I have already said, by new statistical methods also. We can use something else, something that has not been used till now. We can use new materials. Science is something that develops day by day. It's not stable, it's not a static one. So everything can be effective. We try it and see if it's effective or not.
Asking because I'm the field of the laser matter interaction, there is a lot of things using laser, for example, time of flights or other spectroscopical methods. And since we have a lab and there is also in the framework of Athena, the photonics very much, maybe we can improve some things by collaboration either with other labs in our university or in other labs with within the framework of Athena project from spectroscopy. Because there is the ability to go very low.
The detection limit. The detection limit can be very low.
Can be very low in this kind of things. I don't know if you have already some experience on these things, or you have already have in your future plans this kind of.
I have Nektarios in my future plans, and I have already discussed with the Professor Petridis about applying lasers and the determination of some compounds in water. So we will see how this works and tell you and collaborate more, of course. It's in the plans of a PhD that I have already, we work now.
I think Nektarios will be a key point on this. I would like to give the floor to Michael Tatarakis. Michael Tatarakis is the director of our one of our flagship infrastructures in Hellenic Mediterranean University, the IPPL. I remember it as a CPPL. So I'm sorry, Michalis, if I'm doing a mistake on the acronym. So the floor is to Michael.
So thank you, Kostas, for the organization of this.
And George,
George, of course, for these colloquiums. And thanks, Melina, for your nice presentation. As a continuation to Nektarios' thinking, for example, Melina, you said something about heavy metal detection. You know that heavy metal detection is a very critical point. And you also know that the chemical methods, they have some limits, especially when we talk about isotopes. So if we use, for example, nuclear spectroscopy, we can isolate and we can easier detect heavy metals, especially if we are interested to isolate the isotopes of the heavy metals. I would like to inform you that we have neutron spectroscopy and nuclear spectroscopy, and therefore this is an ability to use here at the IPPL. So, as Nectarios said, we could collaborate on this and expand the capabilities of the research you are doing, which I believe it's very nice and very important for the environment. So, whenever you want, we can discuss about the methods that Nectarios said earlier, but also the nuclear spectroscopy that I'm telling you now. And there are also other capabilities that that you may be interested. So in any case, it's a good thing that you presented this talk and this kind of research, because there are many things that we can do in collaboration. And this is also the good thing about these colloquials.
So, Michael, can I ask you something? I mean, in order to detect these heavy metals, the targeted sample should be in solution, or it can be in solid, like a film?
No, it can be solid. It
Okay,
can be
fantastic.
solid, liquid, or even gas. We illuminate the solid, the matter with neutrons produced by a plasma focus device. So we excite the nucleus, and when the nucleus is de-excited, emits gamma rays. And the gamma rays is actually the footprint of the material. Even if you have isotopes, you will see differences.
Yeah.
If I remember well, if I know well, a nuclear magnetic spectroscopy or neutron analysis, you mean? Because the first one, I think we must have a very high concentration to detect them, not in a very low levels. So it's difficult to detect in very low concentrations the heavy metals. Only in materials that they are in high concentrations. For neutron analysis, I don't know, so we can work about and conclude what.
Yes, the sensitivity of the method, of course, depends on how many the contamination. Of course, it depends on the contamination. Contamination is small.
Sorry, I can't see because somebody is.
Just a moment, please.
Yes, I'm saying that of course, the sensitivity depends on the contamination. But if the contamination is small, you have the ability to increase the mass.
Yes, yes.
And have more mass. And therefore, if you have more mass, you have more, let's say,
yes, we can condensate the sample, we enrich it.
Yes, exactly.
And after we bring it for analysis,
yes,
for detection. Yes.
So this is one option, but we can discuss this in details.
Thank you. The floor is to Professor Christakis. Professor Christakis is a professor in the engineering department. So, Professor Christakis, the floor is yours. You should unmute your microphone. Professor Christakis, you should unmute your microphone. Just a moment. Now, it's okay.
Do you hear me?
Yes.
Hello, everybody. I want to express my sentiments because it's fine to be among you, an interdisciplinary group developed under the actions of Konstantinos Petridis and, of course, George Kavoulakis, who has educated us in the former TEI to discuss among us very important aspects and issues. May I call you Melina?
Yes, of course, of course.
Let me do so because we have a very big difference in age. So I want to ask you some questions. The first one is not, of course, in your speciality. in the chemical engineering, as far as I can name your work. Tell me something. Working on this subject, which would be the best environment for you? A mechanical engineering department or the engineering school that you are now? Do you have the need of a chemical engineering department, or it is okay for you to be in the environment you are?
Okay, of course, a chemical department is mostly closed to this subject that I work on, but the School of Engineering that I am now can bring other results that better results, because I can collaborate with people that have knowledge in other fields, and we can join, we connect our knowledge and bring something new one, not something that is already tested before. As you saw before, Professor Tatarakis has told me about the neutron analysis. Professor Papadakis told me about the laser, so we can interact each other and bring something totally new. If I was in a chemical department, okay, it would be the same. Everybody means the same, because we can easily communicate, but we can't produce something new, something different, because all our minds think with the same way. But now we are people that think with different ways, and so we can join our thoughts and bring a new, bring something new, something pioneer, let's say. I don't know if I have covered you to your question.
Okay, yes, and I'm very glad to hear all those opinions and thesis of you on the epistemological approach. And a second question on the same area. Do you can you estimate your motives to develop this research you are doing?
For the research, my
why are you doing all that?
You mean this? Because I have my basic knowledge, and my scientific steps are lead to go to this field. I don't know something else to explain.
I will say, may I interrupt? May I interrupt, Professor Christakis? You know,
of course.
Okay, on my opinion, what Melina is doing, I don't know why she's doing this, but what she's doing is very important. I mean, we know wars are happening about water, and you know, the security to secure water, you know, supplies, and how we can exploit and use seawater for the drinking or for agricultural purposes. So what she is doing regarding processing water and all these techniques that we can identify in a very low sensitivity, in a very low concentrations, and to develop all these high sensitive detection techniques and materials is something very important. It triggers, you know, the science. Not only it does not have, science does not only have an impact to the society. As I mentioned, wars are happening because of the water. Actually, all the wars are happening because of the water. I have, you know, with us, you know, Nisim, and he can probably tell you the conflict between Israel and Syria about water, or the Turkey, what is trying to do to divert water supplies to north of Syria. So I think that what she's doing is very important. It's very important for the island of Crete, because we know that we are suffering from the water supplies. And you can see, Professor Christakis, all this bringing all this conversation, how multidisciplinary can flourish the science and education, of course, at the same time within a university. So I don't know why Melina is doing this. From my point of view, what she's doing is very important.
Okay. We have to work about something. So this is the subject I have chosen to work on. I don't know what else to say to you to answer your question, Professor Christakis.
I will tell you why. I will tell you why I'm asking you the question. In my early postgraduate studies, I was involved in a research in the Patraikos Gulf, you know, in Patras.
Yes.
And the reason why I was involved there was to gain some money. I was paid in order to write and solve the problem of the dispersion of pollutants in the Patraikos Gulf, because at this time there was a big problem with the local industries. So all those issues you have mentioned before were very familiar to me. Not from your point of view, of course, because I'm a mechanical engineer, and what I know, what I did at this time was to copy and develop numerical code from the EPA, the Environmental Protection Agency, and to apply this finite differences code in the case of Patraikos Gulf, and after that some other cases. And my personal motive was clearly the money. I wanted some money in order to survive and to do my PhD thesis, which was okay, related to the fluid mechanics, but was physics of fluids, something very different. Why I'm asking you this question? Because in this multidisciplinary and I would prefer disciplinary group that we are now, and I want to be accepted in this group and discuss over the frontiers of the discipline of each of us, of the scientific frontiers which define our activities. It is a very, very productive and a matter of life to meet different people. That's why I posed those questions, because the first question was related to the existence of a potential between us. The differences develop a potential, and the second one is the ability to take advantage of this potential, because it is the potential of between us is given. All of us, all the persons I'm seeing in this group, we are different. We belong to different areas. The second question is, this difference can develop a potential.
Yes,
What are our motives? I have here in my desk a book written by an American philosopher, John Burke, who has written a book about the grammar of motives. I propose you you can find it in the internet, you can download it, a grammar of motives, because it is very, very productive to see the mechanics of motives. We're living in East Mediterranean, a location of a lot of civilizations. It's time to take advantage of the languages, of our traditions, of the different disciplines, the different
Professor Christakis, we have only 3 more minutes. If you would
okay,
like to
okay, I'm
conclude,
stopping here. I just expressed my joy to be among you.
I
Thank
mean,
you
yes,
very much.
very much appreciated. I think that all of us, we can exchange emails and we continue this conversation. I think that the last questions will come from Pantelis Soupios. Pantelis would like to ask something. Pantelis is like a next staff of us. Now he's a professor in the Kingdom of Saudi Arabia, one of the best scientists that we have. Unfortunately, you know, it's a part of the game, our scientists to move away. So Pantelis, the floor is yours.
Yeah, thank you. First of all, I would like to congratulate Melina and also you and George for organizing this. For me, the most important is that first we are teachers and then we're researchers. The idea of educate the students and change the mentality of respect the environment and do the difference in the current time is the most important from my side. So it's just answering to Professor Christakis' question, why Melina is doing this is to protect and make our biosphere better. I mean, it's very clear. So it's, Melina, congratulate you. I mean, for me as a geophysicist and for all the others like Michael and Nectarios, that they are having different technologies, we should use all these technologies as tool to protect the environment. And you know the basic theory and the concept in order to apply how you can apply all these tools for the protection and the restoration of the environment. So thank you, Kostas.
Thank you very much, Pantelis. I would like, I mean, if there are no other questions, I think that we are an hour now. I should end this session. I would like to thank all of you.
Kostas, just for a minute, I'd like just to say to Melina some key words. I have seen that in any laser laboratory that I have experience in different laser laboratories in Europe, there is an environmental laser department. And there is, for example, light-induced fluorescence in the pollen, laser-induced breakdown in plasma spectroscopy. There are also some other methods, optical methods. For example, the plankton in sea, they can do speckle pattern imaging in order to estimate the number of pollutants inside the plankton, seeing different speckles, laser speckles by a camera. There are also some other methods like the time of light, which is atomic or molecular method with very high sensitivity in the detection. All these, we are open in IPPL to discuss if you want to visit us and to see some different techniques that we have for other things, but maybe it will be very important for your research together with what Mihalis Tatarakis said, which is the nuclear neutral spectroscopy with the machine that he is running in our university. Thank you, Kostas.
This will be my next scientific plans to develop and come to see the laser, all the apparatus there, and see what results we can have.
Let me
samples.
Okay. Let me close this with a small notice regarding sensing and sensor. You know, the sensitivity is one part, but a sensing technique or a sensor element should accompanied by also how fast you detect the thing, selectivity, which is the $1 billion question. Like if you play something, how you can detect, you know, something that you are targeting and is not fooled by other means, and also and the recovery time. I mean, if we are talking about sensors, not about techniques, because Nectarios is talking about techniques. In our case, when we're talking about materials to use as a sensing element, the sensing element should recover, should return back to its original physical or electrical states after the removal of the target molecule or the pollutant. So I would like to thank all of you. I would like to thank also, you know, for this multidisciplinary and different conversation that we had. I think this is the main impact of this of this colloquial talk. It's not only the knowledge, but also all this discussion that I just heard. I would like to thank all the participants. I would like to inform you that the next talk, it's going to be from Pantelis Soupios, and also on the same day with Pantelis Soupios, we organize a very good, I think very good, workshop in mathematics education. So on next Friday, on the 16th of October, we are starting with Pantelis talk, and then we continue with a workshop starting at 3:30 Greek time, 2:30 CET, with speakers from HMU, speakers from all over the world, from Israel, from Sweden. Wolfram, that builds Mathematica, will be with us in order to support. And so how do we use mathematics linked with real life problems like Melina's in order to make this teaching of mathematics more friendly and to give a more impact to our students? As Pantelis mentioned, students is the center of what we are doing. So I would like to thank you. It's a great honor to have it with you, and see you on Friday. I will send an email with the Zoom link, and what is the time? It's Kalispera from Greece.
Go ahead, Kostas. Go ahead, Giorgos.
Bye.
Bye.
Γεια σας, γεια σας, γεια σας.
Thank you very much.